Revision of factorization, factors of algebraic expressions. So let us take this expression to understand this concept. Say 5x square y. So what are the factors for this algebraic expression? It is 5 into x into x into y. So when you multiply these factors, you get 5x square y. So factors of this algebraic expression 5x square y are 5x, x and y. Let us now take this question. Factorize 10x square minus 18x cube plus 14x raised to the power 4. So we have to factorize this. I am going to use method of common factors to factorize this. So what is the common factors in all these terms? So you can clearly see x square is common in all these three and 2 is also common in all these three terms. So I am going to take 2x square common. So let us write down the question first. It is 10x square minus 18x cube plus 14x raised to the power 4. So as we have discussed now, just now that we can take 2x square as common. So what is left here if you take 2x square common? 5. Here it is minus, here it is plus. So plus into minus gives you minus. 2x square already you have taken common. So what is left here? 9x. Plus into plus gives you plus. 2x square you have already taken common. So what is left here? 7x square. So what are the factors for this algebraic expression? They are 2x square and 5 minus 9x plus 7x square. Factorization by regrouping terms. Question: factorize AB in brackets x square plus y square plus xy in brackets a square plus b square. So can we take anything common here? No. So let us open the brackets and try to regroup them and then take common. So I am going to use distributive property here to open it. So AB into x square gives you AB x square. Plus into plus gives you plus AB into y square. Here what do you get? Xy into a square. So here you have got plus xy into a square. Plus into plus is plus. Xy into b square gives you xy b square. So with this arrangement we have already taken common and we got this, and further we cannot factorize it. So let us regroup it. So I am going to move this here and this I will move it here. So from these two I can take ax common. So, and from these two, I can take b, y common. And let us see, can we further solve it then? So, I am going to regroup it. So, here it is a, b, x square. I am bringing this here. So, you get here xy into a square plus, I am bringing this here. So, you get ab, y square plus xy, b square. So from these two terms, you can see, you can take a common and x common. So ax is common. So what is left here? Ax you have already taken common. So what is left here? B and x. So bx is left here. A and x you have already taken common. So what is left here? A and y. Plus sign is here. So let us put plus. So ay is left. From this plus is here, I'll put down plus. From these two terms, you can take y and b common. So by I am taking common. So by you have already taken common. So what is left here? Ay. And plus is here. So I'm going to put plus. And here by you have already taken common. So what is left here? Bx. So now you can see from these two terms, ay plus bx can be taken common. So I am going to take bx plus ay common now. So from the first term, I am going to take bx plus ay common. So what is left here? Ax. And what is left here? By. Because ay plus bx you have already taken common. So what is left here? By. So plus by. So the factors for this algebraic expressions are bx plus ay and ax plus by. Factorization using identities. Question: factorize. You have to factorize this algebraic expression. So if you see this algebraic expression, it matches with a minus b whole square identity. What is a minus b whole square identity? It is a square minus 2ab plus b square. So here you can see this is a perfect square. This is a perfect square minus twice of a into b. So you can match it with this. This is 11a whole square. This is 4b whole square. And this is minus of twice of a here is 11a and b here is 4b. So you can clearly use this identity. So your a here is 11a, b here is 4b. Then you can use this identity and factorize it. So let us factorize it using this identity. So I am going to write down the question first. It is 121a square minus 88ab plus of 16b square. So as we have discussed just now, we are going to use a minus b whole square identity. So this is 11a whole square. This is minus of twice of a. Here is it is 11a and b here is it is 4b plus of b square. Here b is 4b whole square. So now this is 11a minus 4b whole square. So 11a minus 4b whole square. So using a minus b whole square identity, if you open it, you will get this 11a square minus twice of 11a into 4b plus of 4b square. So since they have asked you to factorize it, let us write down in factors form. So the factors are 11a minus 4b into 11a minus 4b. So what is the identity we have used here? A minus b whole square identity, that is a square minus 2ab plus b square. So this is the identity we have used here to solve this question. Factorize. We have to factorize this algebraic expression. So this is a perfect square, this is a perfect square, and there are three terms here. So it matches with a plus b whole square identity. What is your a plus b whole square identity? This a plus b whole square is equals to a square plus 2ab plus b square. So you can clearly see this is 7a whole square, this is 6b whole square, and this is twice of 7a into 6b. So you can use this identity here and factorize it. So let us use this a plus b whole square identity here and factorize it. So you can rewrite this as 7a whole square plus twice of the first term here, that is 7a, into the second term here is 6b plus of 6b whole square. So which identity we are using here? A plus b whole square identity. So by using a plus b whole square identity, that is a square plus 2ab plus b square. So here your a is 7a, b is 6b. Twice of ab is twice of 7a into 6b. So a plus b whole square. So I can rewrite this as 7a plus 6b whole square. So this is equals to 7a plus 6b whole square. So you have to factorize it. So let us rewrite it as 7a plus 6b into 7a plus 6b. So these are the factors for this algebraic expression. Factorize. You have to factorize this algebraic expression. You can clearly see this is a perfect square, 16 is a perfect square, 144 is a perfect square. But x is power 5 and x cube, they are not the perfect square. We can make them perfect square by taking x common, and then we can use a square minus b square identity. What is a square minus b square identity? It is a square minus b square is equals to a plus b into a minus b. So when you make this as a perfect square, it will be like a square minus b square. So we can use this identity and solve. So let us use this identity here. So we are going to make this as a perfect square by taking x common from here. So when you take x common, what you are left here with 16 x raised to the power 4 minus 144 x square. Now this is a perfect square, this is a perfect square. Let us write it down. So this is 4x square whole square minus this is 12x whole square. So now this is of the form a square minus b square. So which identity we are going to use? A square minus b square. So by using a square minus b square identity, that is equals to a minus b into a plus b. So your a here is 4x square and b here is 12x. So let us write it down. This is x into a here is 4x square. So this is 4x square minus b here is 12x into a is 4x square plus b is 12x. So from here you can take 4x common and from here also you can take 4x common. So let us write it down. So when you take 4x common here, what is left here? X minus you have taken 4x common from here. So what is left here? 3. From here again we are taking 4x common. So what is left here? X. This plus and what is left here? 4x you have taken common. So 3. So 4x into x you get here 16x cube. And here what do you have? X minus 3 into x plus 3. Now let us take this question. Factorize. So you can clearly see this is a perfect square, but this is not a perfect square. So you cannot use a plus b whole square identity. You cannot use a minus b whole square identity because this is not a perfect square anyhow, and here it is a plus sign. And neither we can use a square minus b square identity because there are 3 terms. So which identity we will use here? Here we are going to use another identity which is x plus a into x plus b. That is x plus a into x plus b. So that is equals to x square plus a plus b into x plus ab. So here you can clearly see it matches with this identity. This is x square, this is a plus b and this is a into b. So you have to use this identity to factorize. That means here sum of the two terms a and b should be 15 and a into b should be 56. So which are the two factors? When you multiply it, you should get 56 and when you add, you should get 15. It is 8 and 7. So when you multiply 7 into 8, you get 56 and when you add them, 7 plus 8, you get 50. So we are going to use this identity here and solve it. Let us solve it now. So here let us write down the question. It is x square plus 15x plus 56. So we are going to use this identity x plus a into x plus b. Using that we are going to factorize it. So by using x plus a into x plus b, that is equals to x square plus a plus b into x plus ab. So when you match with this, you can clearly see this is the expression given to you. You need to find out these factors. So this is x square, a plus b is 15 and a into b is 56. So just now we found it out that a is 7 and b is 8. So let us write it down in that form. So this can be written as x square plus a here you got it as 7, b is 8 into x. So 7 plus 8 is 15. We have split 15 as 7 plus 8 plus a into b, that is 7 into 8. So here your a is 7 and b is 8. So this is x plus a is 7 into x plus b, here it is 8. So the factors for this algebraic expressions are x plus 7 and x plus 8. Now let us take this question, x square minus 7x plus 12. So again it is of this form. So we are going to use this identity and solve. This expression is this side which is given to you. So you have to use this formula and write it like this in the form of factors. So we are going to use this identity here to solve. So let us write it down by using x plus a into x plus b is equals to x square plus a plus b into x plus ab. So we will write this one exactly like this so that it is easy for us to write down the factors like this. So let us write it down. So here you have x square plus, here it is minus. So we can write it here plus because we are writing in this form, plus a plus b. Here a plus b is minus 7. So what is that? You can take it here minus 3 and minus 4. So then it will give you minus 7. And when you multiply minus 3 into minus 4, that is ab, you will get it as 12. So let us write it down. So your a here is minus 3 and b here is minus 4. So minus 7 I have written like this into x plus 12 is a into b. So minus 3 into minus 4. So I have written this expression exactly like this here. See, x square plus a plus b. Your a is minus 3, b is minus 4 into x plus a into b. A is minus 3 into a is minus 4. So minus 3 into minus 4 is plus 12. Minus 3 minus 4 is minus 7 into x is minus 7 plus x square. So we have written this expression like this. That is this side of this formula. So now x plus a into x plus b are the factors. So we will write down in that form here. So what is your x plus a here? Your x is x. You can clearly see it is matching. A here is minus 3. So x plus a into x plus b. B is minus 4. So we can simplify this. That is plus into minus is minus. So this is x minus 3. Plus into minus is minus. So this is x minus 4. Division of algebraic expressions. To understand the concept, let us take these questions one by one. Question. Carry out the following division. So this is the first question given to you. So here minus 20 and 10 you can cancel out. So if you cancel out here, what do you get? Minus 2. And this, how are you going to solve it? We will use the laws of exponents. So here you have minus 2 and x raised power 4. When this goes in numerator, it is minus 2. We have used this law of exponent, a raised power m upon a raised power n is equals to a raised power m minus n. So using this law, we have simplified it. So what do you get here? Minus 2 x square. Next question. So you have to divide this expression by this expression. You can cancel 8 and 24. So let us cancel it out. Cancel 8. You get here 3. So here in the numerator you can see that in all these three terms x, y, z is common. So let us take that common. So here you have 3. We are taking x, y, z common. So when you take x, y, z common from here, what is left here? X plus. When you take x, y, z common from here, what is left here? Y plus. When you take x, y, z common from here, what is that you are left with? Z divided by, you have x, y, z. So you can see you have x, y, z in the numerator and you have x, y, z in the denominator. So you can cancel it out. X, y, z and x, y, z. So you are left with 3 into x plus y plus z. X plus y plus z. Next question. You have to divide this expression by this expression. So you can cancel 44 and 11. Let us cancel it out. 11 and 44. So you get here 4. So from these three terms, you can take x square common. Let us take x square common. So in the numerator, you have 4. X square you are taking common. So here what is left? X square minus 5. X square you have taken common, so x. So minus 5x minus 24 upon x into x minus 8. So you can cancel x square and x. So let us cancel it. Now here x is left. You have used the same division law here. So when it goes in numerator, it is x to the power 2 minus 1. So you get here x. So now you can see this is similar to the identity x plus a into x plus b. This identity x plus a into x plus b, that is equals to x square plus a plus b into x plus ab. So when you compare these two, you can see x square is x square, a plus b is minus 5 and a into b is minus 24. So what could be the possible values of a and b? It is minus 8 into 3. If you do, you get minus 24. Minus 8 plus of 3, you get minus 5. So you can use this identity and solve. I am going to show you another method where we are going to split this term and write down. So here we have is equals to 4x in brackets x square. I am splitting minus 5x as minus 8x plus 3x. So minus 8x plus 3x, you get minus 5x minus 24 divided by x minus 8. Now I am going to take from these two terms x common, so you will get here x minus 8. From these two terms, if you take 3 common, then you get x minus 8. Let us do it. So here you have 4x. You take x common from here, so you have x minus 8 plus 3 you are taking common. So here you have x plus into minus is minus, so here it will be minus 8. So from these two terms, now you can take x minus 8 common. Denominator we have x minus 8. So in numerator you have x minus 8 you are taking common. So when you take x minus 8 common, x is left here plus 3 is left here upon x minus 8. You can cancel x minus 8 from numerator and denominator. So what you are left with? 4x in brackets x plus 3. Next question. So here you can see you can cancel both z from numerator and denominator. So let us cancel it out. And from here you can take 5 common. So let us take 5 common. So when you take 5 common, what is left here? Z square minus, you have taken 5 common, so you are left here with 16 divided by 5 into z plus 4. So here again you can see you can cancel 5 and 5. Now we can factorize it using the identity a square minus b square is equals to a plus b into a minus b. So let us factorize it using this identity. So this I will rewrite exactly in this form first. So that is equals to z square minus of 4 square is 16 upon z plus 4. So you can clearly see your a is z and b is 4. So a plus b here is z plus 4. A minus b is z minus 4 because a is z, b is 4 divided by z plus 4. So here you can cancel z plus 4 and z plus 4. So what is that you are left with? Z minus 4. So this is the answer. Question. Find and correct the errors in the following mathematical statements. So first you have to find out the error and then you need to correct it. So let us take the first question. Here you have to use distributive property to open the brackets. So when you multiply x into 3x you get 3x squared. That is correct. Then when you multiply x to 2 you get plus 2x. But here it is written as 2. 2 is wrong. So what is the correction you have to do? You have to write down 2x. So let us do the correction. It is 3x square. This is fine. Plus 2x. Next question. Here 5y plus 2y plus y is 8y. So that is y. But here it is written 0. So what is the mistake? 0. That is the wrong answer. Let us write it now correctly. So 5y plus 2y plus y minus 7y. So if you add all these three, you get 8y minus 7y. So the answer is y. So this is the correct answer. It is not 0, it is y. Next question. This is 2x whole square plus 5x. So 2x whole square is 4x square. But here it is written as 4x. So when this is wrong, then this is also wrong because this is 4x square. You cannot further add it up. So this is also wrong. So these two are wrong. So now let us correct it. So here we are using laws of exponent. Which law? A plus b, a into b whole square is equals to a square into b square. So here your a is 2. So a square means 2 square, that is 4. B here is x. So b square is x square. So it is 4x square, not x. So let us write down the correct answer. So it is 4x square. When you take the whole square, it is 4x square plus 5x. So that is the answer. You cannot further simplify it because these two are unlike terms. Next question. Here you have 3x square plus 1 in the numerator and 3x square in the denominator. So here it says 1 plus 1. But when you divide it here you will get 1. But here you will get 1 upon 3x square. So the answer for this one is wrong. What is the mistake here? This and even this. So let us correct it now. So the question here is 3x square plus 1 divided by 3x square. So when you divide it, first you have to divide this by this. So how will you write it as? 3x square upon 3x square plus 1 upon 3x square. So here you can cancel this. So here you will get 1, but here you get 1 upon 3x square. So let us write down the correct answer now. This is 1, that is why this is correct. Plus, instead of 1, it is 1 upon 3x square. And we cannot further simplify it because these two are unlike terms. So you will not get the answer as 2. This is the answer. Next question. Here you have z plus 5 whole square is equals to, it says z square plus 25. That is fine. But here it is using the identity a plus b whole square. So here twice of ab is missing, means twice of z into 5. So this is incomplete. Here plus this is missing. So nothing wrong here. It is missing. It is incomplete. So let us write down the correct answer. So when you use a plus b whole square identity, you get here a square plus b square. Here it is 5 square. So that is 25 plus twice of a is z, b is 5. So what is the answer? You get z square plus 25 plus 10z. So this 10z was missing from this expression. So this is the correct answer.